Is the screen clearly visible and am I audible to all? Please unmute your mic and give me the answer. Anyone?
Yes, ma'am. Okay.
Okay, fine. Okay. So good morning to all. Today we are going to start the power electronics session number 2 for gate coaching under the Prerana scheme for SC/ST students. Today is the Saturday, 21st November. Oh, sorry, 28th November. Let me clear that. Let me change that. So today is 28th November, Saturday. The session is from 10 to 12. 2 hours we are going to see at a stretch applications of power electronics. And in the applications of power electronics, we are going to see the detailed applications of inverter, that is single phase and three phase inverter. So can anyone give me the answer? What is inverter? You can unmute your mic and give the answer. What is inverter? Anyone? Yes, Rajesh, Snehal, Pragati. Yes. Sir has already started inverter. I think Sridhar sir has already started inverter, no? So if you know the answer, you can give me the answer. Rajesh, Ramdas, Pragati, and Snehal. Am I audible to all?
Yes, ma'am. Conversion of AC voltage to DC.
Conversion from AC to DC. Okay. Any other? It is a device which can do the conversion from DC to AC. That Snehal has given the answer. Ramdas is also giving the answer DC to AC. Okay, fine. So Snehal and Ramdas, they have given correct answer. Rajesh, the device which we are converting from AC to DC, it is called as rectifier or controlled rectifier. In power electronics, it is called as a controlled rectifier. Okay, and the conversion from DC to AC, it is called as an inverter. So see, in our home applications, we generally call that inverter we have connected in our home, which is used whenever the supply goes from MSB or from any distribution board. Okay, in which state you are staying. So suppose that electricity supply from the government side, if it is off, we say that now we have to switch on inverter. Okay, why we have to switch on inverter? Because inverter is having a stored source of a battery which is having the input voltage stored in the form of DC, and that battery DC voltage we are going to convert in the form of AC with the help of inverter. So inverter is an application where we are converting DC voltage into AC voltage. Is that clear to you, Rajesh?
Yes, ma'am. Yes.
Okay, very good. Okay, so the session is what is inverter, what I said just now. There are four applications. First application is converter, which is given you the conversion from AC supply to DC supply. Then the second application is AC voltage regulator, which is having input AC and output is also AC. So what it does, AC voltage regulator converts fixed AC into variable AC. So it is just like our transformer. In our transformer also we are going to vary the output voltage from primary to secondary. So whenever I want to change the magnitude of the output voltage in the AC form, we generally use a transformer either to step up or step down. Okay, so AC voltage regulator, we are going to regulate the output. We cannot step up. In the transformer, we can step up the voltage, but in regulator, we cannot step up the voltage. Only thing is that we can regulate the voltage in such a way that if suppose I have 230 volt AC, then with the help of transformer, I can make it 230 volt greater than 230, like 440, 460, 1000, 2000, like that. But then in the with the help of AC voltage regulator, I cannot do that. Then what is the use of regulator if I have 230 volt fixed? And if I want to vary below 230 volt, like I can vary the voltage from 0 volt to 230 volt. In between that range, I can vary that output voltage at any value with the help of AC voltage regulator. So it is called as a regulator. Regulator means variable. Variable output I can get. So in our home applications also, we are decreasing or increasing the speed, but speed of a fan. What I want to say, speed of a fan. But extreme level, whatever the capacity of the fan to run at the maximum speed, beyond that I cannot go. That is fixed. Maximum capacity of the speed of a fan is fixed. So what I can do, I can regulate the speed of a fan with the help of what? With the help of fan regulator. It means I can vary the speed of a fan from zero level to its maximum level. The same meaning is in AC voltage regulator. I can vary the output voltage from zero level to its maximum capacity level. So it gives me variable output. Okay, so it cannot give the increased output like a transformer, like a step up transformer. Okay, but transformer gives you one fixed value. Like suppose if I'm taking 230 volt AC and I want to make it 100 volt AC. So what I'll do, I'll use step down transformer, which will have 230 volt down to 100 volt. But then I get continuous 100 volt only. Then I cannot change from 100 to 80 or 100 to 120. But in the voltage regulator, I can even move from 100 to 80 or 100 to 120. Okay, that is the difference. Then the third application is chopper. What is chopper? Chopper is also giving me fixed DC to variable DC. See, now if you will compare first, second application to each other, they are having same input. Converter input is also AC, regulator input is also AC, but they have the different output. Converter output is DC, whereas regulator output is variable AC. Now, if I compare first, second application to third application, that is chopper. Chopper input is DC, but converter and regulator they have the input AC. So what is chopper? Chopper gives fixed DC to variable DC. Now fixed DC to variable DC means what? Like you are say SMPS. To measure CPU, if you are opening your CPU, okay, and seeing, you will see small aluminium coated box which is having that power supply, which is converting one level of DC voltage to the another level of DC voltage. If suppose I have 50 volt DC, and from that 50 volt DC, suppose I want 5 volt DC, it means I want to move from one level of magnitude to the another level of magnitude, and that too in DC form. Then I cannot use a transformer, because transformer we can use only with the AC supply. We cannot use a transformer in DC supply. Then what I can use? So to convert or to change the level of the output voltage in DC supply from one level to the another level, we have to use a chopper. So chopper is also acting as a transformer, but it is not a transformer. Why? Because transformer works only in AC supply. Transformer doesn't work in DC supply because we do not have d5 by dt, that is rate of change of flux. Because transformer works on the law of EMF should be variable. Okay, your rate of change of induced EMF gives you your what we can say, the secondary side voltage. So that d5 by dt you are getting because you are having primary voltage sinusoidal. So as sinusoidal supply continuously varies at each instant, you are getting flux changing, and that flux changing gives you rate of change of flux, and that rate of change of flux gives you induced EMF. So in DC supply, your output voltage remain constant. If input voltage remains constant. If input voltage is constant, input current is constant. If input current is constant, flux is constant. If the flux is constant, you will not have any change in flux. If you do not have any change in flux, you will not get any rate of change of flux. If any rate of change of flux is zero, you will get d pi by dt zero. If d phi by dt is 0, your E is 0. So transformer doesn't work in DC supply. Okay. So equivalent function of a transformer your chopper does in DC supply, that it can change the voltage level from one to the another. Okay. And the last application is inverter, that is DC to AC. Now, is it clearly understood to everyone? What are the different four applications and what they have exactly the difference between each other? Because this question you may have in your oral exam of power electronics. What are the different applications of power electronics and how they differ from each other? Is that clear to all? Okay, fine, very good. So what is inverter? I said it converts DC to AC, and what is the basic difference? Its output voltage AC is having variable magnitude and variable frequency. Variable magnitude, it means what? Suppose I have given 50 volt DC to the inverter and I want 230 volt AC, 50 hertz frequency. I can get that from inverter. If suppose I have 200 volt AC and 100 hertz frequency with the same input of 50 volt DC, then also I am able to get that 200 volt AC and 100 hertz frequency. If suppose I want 50 volt with the same input, 50 volt DC, but now I want 200 volt and 150 hertz frequency, means I am not changing magnitude, only I am changing the frequency from 100 hertz to 200 hertz. Then also possible with the inverter. Okay, so any level of magnitude and any level of frequency I can achieve related to the ACR, because we have seen there are four major semiconductor devices, that is SCR, then BJT, then IGBT, and then MOSFET. So which devices generally more prefer in inverter? So which devices we generally prefer, which, that is the last point, IGBT and MOSFET. Now why IGBT and MOSFETs are widely used in inverter? Why not SCR? Because in the first class, if you remember, that SCR is a gate control device, whereas MOSFET and IGBT are also gate control device. They also have gate terminal. Okay, but what is the difference between IGBT, MOSFET and SCR? IGBT and MOSFET devices, they can turn on with the gate as well as they can turn off also with the gate. It means if I am applying a gate pulse to IGBT and MOSFET in a proper polarity of a proper magnitude, then I can turn on them. And as well as I remove gate pulse, as soon as I will remove gate pulse from IGBT and MOSFET from their gate terminal, they will be turned off. Means with the help of one single terminal, I can turn it on as well as turn it off. But that doesn't happen with SCR. In SCR, I can turn on with the help of gate terminal, but then I cannot turn it off with the help of gate terminal. Okay, because SCR does not have any control over the gate terminal once it is completely under conduction state. That is called as a latching condition. Okay, so under the turn off process, what you have to do, you have to use the commutation circuit. Now there are various types of commutation. One is the natural commutation, another one is the forceful commutation. If you know, if you do not, I'll explain briefly. Natural commutation means what? Natural commutation means once we are using AC supply, when we are having converter applications, control rectifier application, we are using AC input. In AC input, we have the sinusoidal supply or sinusoidal voltage to the input terminal of converter. Now, sinusoidal input consists of a positive half cycle and a negative half cycle. So, whenever the voltage and the current having sinusoidal nature, when they complete their positive half cycle and enter into negative half cycle, they passes through one zero value. They passes through one zero value. Okay, I'll give you the example. Suppose this is the waveform we have. Okay, just concentrate on first waveform. Is it visible? First input voltage waveform of a sinusoidal with the red and the black color. Is it visible?
Yes, ma'am. Yes.
Okay. So, see, in natural commutation, what happened? If the input is AC, then this positive half cycle, which is the red part, when it has completed and when that particular voltage is now entering in the negative half cycle, that is the black part, here you have one current zero value or you have one 0 point. At that 0 point, that is called as a natural 0 point, at that 0 point, the current flow through the SCR automatically or naturally goes to zero. Because the current flows through the SCR naturally goes to zero, that zero value is always lesser than holding current. Okay, zero current means what? It is less than holding current. And what is the condition to commutate or to turn off SCR? That current flow through the SCR should be less than holding current. Now, holding current is a finite value. It may be in milliampere, microampere, whatever. But every finite value will be obviously greater than 0 ampere. So, if the current flow through the SCR is naturally going to zero value, it means at that point, that magnitude, zero magnitude, is always lesser than any value of the holding current. It means at that point, any SCR goes to turn off or goes to commutation naturally. That's why this commutation is called as a natural commutation. So these natural commutation when we are getting only when the input voltage is sinusoidal AC voltage. What I said, when this natural commutation we are getting whenever the input to the application is AC. So that this natural commutation we cannot have in inverter. Why? Because in inverter, which kind of input we have? We are having DC input. If the input is DC, we cannot have a sinusoidal voltage at the input side. Once we cannot have the sinusoidal input voltage to the input side, we cannot have natural 0 point. So, when we do not have a natural 0 point, means we cannot have natural commutation. So, if we do not have a natural commutation, it means forcefully I have to commutate the SCR. Now, forcefully, if I want to commutate the SCR, because of that word forcefully, that commutation is called as a forceful commutation. Okay. So when forceful commutation we supposed to use? Whenever the input is DC. Whenever the input to any application is DC and if that application is having SCR in that construction, then which commutation method we supposed to use? We supposed to use only forceful commutation. So what is the use of forceful commutation? What forceful commutation does? It is used to reduce the anode current of SCR lesser than the holding current value. Clearly understood everyone? Forceful commutation कशाला म्हणतात? Forceful commutation means what? The commutation method which decreases the anode current of SCR lesser than the holding current value. Okay? Now, this forceful commutation method or this forceful commutation circuit, which elements they are using? They use inductor and capacitor. So, external elements such as L and C are used to turn off the SCR. So, commutation circuit, which commutation circuit? Forceful commutation circuit. So, forceful commutation circuit consists of which elements? Inductor and capacitor. Why, how, we will see later. But at least remember that in inverter, we cannot have natural commutation. We should have or we have to use forceful commutation because in inverter, the input voltage is DC. So to avoid these all complications that if I am using SCR in inverter, I require two different circuitry. One to turn it on, that is called as a gate circuit, and another one to turn it off, that is called as a commutation circuit. So imagine if I have a bridge in inverter, full bridge inverter, then how many devices I'll have? Four. So four SCR. So if I have a four SCR, then it means it will require four gate circuits and four forceful commutation circuit. It means for four devices, I need to handle total 8 circuits and I have to synchronize them. So circuit is so complicated, no? So to avoid that, we are using IGBT and MOSFET. So by using IGBT and MOSFET, what the advantages I can have? I'll only use the gate circuit, and if the devices are four, I'll use four gate circuits, which will take care of their on process also and off process also. So instead of having eight circuits, I can only work with the four different circuits for four different devices if I'm using IGBT and MOSFET instead of SCR. So in inverter, IGBT and MOSFETs are widely used. Till that, everyone is clear? Are you getting what I want to explain you? Okay, thank you. Okay, so now we will move towards the types of inverter. Okay, now do you know any types of inverter with your class reference? Your regular classes of power electrons are also going on. So will you explain me what are the different types of inverter? Anyone? Or any type which you understood in the class? Anyone can unmute the mic and give me the answer. Any type of inverter. Yes, interact, please interact, because no, that monotonous session will have no, you will be bored. Okay, so interact. I'll be happy to talk with you. I said no, for me you all are new. I'll be very happy to talk with you. Yes, Pragati, you are new in this class. Ramdas also new in this class, I think, if I'm not wrong. Yes, square wave and sine wave. Ramdas has given answer square wave and sine wave. Okay, square wave and sine wave, these are the different types of input. Okay, very good answer. But these are the type of waveforms which you can get it at the output side of inverter. Okay, so classification is based on that. Yes, understood. But the basic types of inverter that is called as a single phase and three phase. First, we will start because as an electrical engineer, we will start with the output type of output which we are going to get from inverter at the output side. So AC. AC is my output at the inverter. So if AC is the output at the inverter, which kind of AC supply I'll get, whether it's a single phase or three phase. Okay, because we know that single phase supply is different and three phase supply is different. Okay, so single phase supply we will see. When I want single phase supply, there are two types of inverter. One is the half bridge inverter, another one is full bridge inverter. Okay, so half bridge and full bridge. What is the difference between half bridge and full bridge? If it is a half bridge inverter, how many devices you will have? If it is a full bridge inverter, how many devices you will have? Yes, half bridge, full bridge. You know, no bridge rectifier. So how many devices we use in bridge rectifier? How many diodes we use in bridge rectifier? Yes, bridge rectifier. How many diodes we have? Very good. Four diodes. Very good. So Pragati, Rajesh, good answer. Snehal, two diodes. You want to say half bridge, right? Because half bridge requires two diodes. Okay. So you are also correct. So Snehal has given the answer for half bridge, and Rajesh and Pragati has given the answer for full bridge. Okay. Very good answer. Okay. So now we will see first of all half bridge. What is half bridge inverter? Okay. So now see, this is the half bridge inverter. We have DC supply. So these Vs by 2, Vs by 2, I have two batteries which of half the magnitude. It means suppose if I have 50 volt, I want to apply. So how will I give this 50 volt to the circuit? 25 volt at the upper side battery and 25 volt at the lower side battery. Okay, and these are the two thyristor 1 and thyristor 2, and then the freewheeling diode, diode D1 and diode D2. Now for your basic understanding, I am using these circuits with thyristor because you are more familiar with thyristor. Then later on I will shift from thyristor to IGBT. Okay. So now just For sake of understanding, here I have not displayed any commutation circuit or any firing circuit. We will assume that they are already connected on the board, which are going to take care of the on process as well as off process of thyristor 1 and thyristor 2. Okay. So now first of all we will say thyristor 1. To conduct thyristor 1, we have given this gate pulse Ig1 to thyristor 1 at its gate terminal G1. Okay. This gate pulse is of a positive magnitude of a proper amplitude which will turn on this thyristor T1. Okay. Now when this Ig1 we are giving to this gate terminal of thyristor T1 will turn on. As soon as thyristor T1 will turn on, it will act as a closed switch. It means it will be a short path. Okay. As soon as thyristor T1 will conduct and allow the current to flow in the arrow direction, that is in downward direction, how the current will flow from supply? The current will flow from the supply, that is upper plate of Vs by 2 upper battery, this terminal. Then from the upper plate, it will go to the circuit to the anode terminal of T1, that is the upper terminal of T1 anode. Then through this arrow, the current will come to downward direction. Then it will reach to the another end terminal which is called as a cathode. Then from cathode it will enter or it will come to this junction point. From this junction point it will not go to T2 because T2 is off. As T2 is off, it is acting as an open switch. So current cannot flow through the open path. So from this junction point, the current will start to go to the B terminal of a load. From B terminal of the load, it will go through the load and it will reach to the another end terminal, that is called as the A terminal of the load, and then back to the negative plate battery, that is upper battery. Okay. So in this part, the current is flowing in the upper part of the circuit from the upper battery to T1 to B to A. So the current direction is clockwise, and in this clockwise direction my B terminal of the load is positive and A terminal of the load is negative because current is flowing through the load from B to A. So as B is positive and A is negative, I am getting that Vs by 2 connected in parallel in such a way that positive plate of upper plate battery connected to B and negative plate is connected to terminal A. So this Vs by 2 voltage of the positive magnitude I am getting across my load. So output voltage during the conduction of T1 I am getting the positive half cycle of the magnitude what? Of the magnitude Vs by 2. Everybody understood that? In the conduction of or during the conduction of T1, my output voltage Vs by 2 is positive. Why Vs by 2 is positive? Because the current is flowing in clockwise direction and B is positive and A is negative. So B terminal is connected to positive plate of the battery and A is connected to the negative plate of the battery. Okay. Now come to the second part. Now at this age, at this point, as Ig1 reached to zero level, Ig1 has reached to zero level. It means the gate pulse is now no more after this point. And commutation circuit, assume that commutation circuit has commutated SCR T1 at this point. Okay, so T1 is now off. Now at this point we have connected Ig2 or we have applied Ig2. Ig2 will take care of which device? Ig2 we will apply to T2 SCR, that is gate terminal of T2. So now from this point onwards, your Ig2 is going to conduct T2, that is lower thyristor. So as lower thyristor is under the conduction state, now the current will flow in such a direction that now the lower part of the battery will come in action. As the lower part of the battery is coming in action, how the current will flow? Upper plate of lower battery Vs by 2, that is positive plate of lower battery Vs by 2. The current will flow from this upper plate or positive plate of lower battery to A terminal. See, now this A terminal of the load is now connected to which plate? Positive plate. It means when T1 was under conduction mode, A terminal was negative because A was connected to the negative plate of upper battery. Now when T2 is under conduction mode, this A terminal is now connected to which terminal? That is positive terminal of lower battery. So now A is positive. So current is now flowing from lower battery, then to terminal A, then to terminal B. So now through load, current is flowing from which terminal to which terminal? A terminal to B terminal. Okay, current is still in clockwise direction. Just see. Positive plate, terminal A to terminal B. But now current is flowing from A to B. Still in clockwise direction only, but from A to B. So now A is positive and B is negative. Then from B again coming to the junction point. Then from junction point to T2 anode. Then from anode through the arrow it reaches to the cathode of T2. And then from cathode of T2 it is again coming back to the negative plate of the battery Vs by 2. So at upper part also current was clockwise. At lower part also current is clockwise. But when upper part was operation, the current was flowing through the load from B to A. But when lower part is in operation, the current is flowing from A to B. As current is flowing from A to B, A is positive and B is negative. So with respect to this polarity of output voltage, which was first of all positive, now the second polarity of the output voltage will be obviously negative. Why? Because now in this operation, terminal A is negative and terminal A is positive and terminal B is negative. So now the polarity A is positive and B is negative. Your output voltage is negative with respect to the previous polarity. So this is called as a minus Vs by 2. So because of this operation, the one part has given positive half cycle and the another part has given negative half cycle. It means it is the alternating supply I am getting. Just see, for some duration it is positive, for some duration it is negative. So even though the input is battery, even though the input is DC, but in which way I am getting the output, I am getting the output alternating. One part positive, another part negative. So this is called as a square wave output. The way I think Ramdas has given the answer, that in which kind of output voltage I am getting at the output side. So I am getting the output in the form of a square wave. Okay, but this square wave is the alternating output. So the output of the inverter is AC. This AC output I got with the help of DC input. So that application is called as a inverter. Everybody understood it clearly? How half bridge inverter has worked? Okay, good. So Snehal has given the answer yes. Rajesh also yes. Ramdas also and Pragati also. Good, very good. Okay, so I'm happy. Vaishnavi, are you able to understand? Vaishnavi, are you there? Yes, you can unmute your mic and you can give me the answer. No problem. Vaishnavi, okay, fine, fine. Very good. Okay, so Vaishnavi, try to interact in the sessions either through the chat or by unmuting your mic. I do not have any problem. Okay, now we will move towards the full bridge inverter. Why Ramdas has left the meeting? Okay, let's see. Now we will move towards the full bridge inverter. Okay, now what is full bridge inverter? That is very exciting because many problems in the gate examinations comes on full bridge inverter topic. Okay, so we are going to discuss the questions also. Now this is full bridge inverter. So in full bridge inverter, as I said, the bridge consists of four devices. So here also we have four thyristors: T1, T2, T3 and T4. Okay, and along with each thyristor we have one freewheeling diode. So T1 is connected in antiparallel with D1, T2 is connected in antiparallel with D2, T3 connected in antiparallel with D3 and T4 connected in antiparallel with T4. Okay, so this is called as a full bridge. So because of full bridge we have four devices. It means for each half cycle two devices will conduct at a time. Okay, So now for full bridge inverter, we are going to conduct two devices at a time. So which two devices we are going to have? First IG1 and IG2. So IG1 and IG2 will conduct which two thyristors first? T1 and T2. So with the help of gate pulse IG1 and IG2, we are going to conduct the thyristor T1 and thyristor T2. So how now the current will flow? The current will flow from positive plate of the DC input, that is the battery input. So positive plate to T1, the current will go. Then from T1 anode through arrow, it will reach to the cathode of T1. From cathode of T1, it will come to this junction point. From this junction point, it will go to the A terminal of the load. From A terminal of the load, it will go to the B terminal of load. Then from B terminal of the load, it will go to the another junction point. Then from this junction point, T2 is under conduction mode. So it will go to T2 anode. From T2 anode through the arrow, it will reach to the T2 cathode. And from T2 cathode, it will go to the back negative plate of the supply. And the circuit completes. So once again I'll show the path. The current is flowing from Vs positive plate through T1, from T1 to the A terminal of the load. Then from A to B, the current is flowing through the load. From B to T2, and from T2 again back to the negative plate of the Vs. Okay, so current has flown through the load from A to B. It means A is positive and B is negative. And to that A terminal, which plate has connected? Positive plate of Vs through T1. And B is connected to what? B is connected to negative plate of Vs through T2. So how much is the total voltage we are getting between A and B? The total voltage we are getting Vs. And what is the polarity of that Vs? A is positive and B is negative. So assume that when A is positive and B is negative, we will call it as a positive polarity of the output voltage. Okay. Now see the next part. What is the next part? When third and fourth SCRs are on with the help of IG3 and IG4. So now here we are conducting T3 and T4. So now when T3 and T4 are conducting, how the current flows? See. Again we will take positive plate of Vs. From positive plate of Vs, the current starts flowing in the upper direction. Then it will reach to the T3 anode. From T3 anode, it will go through T3. From T3 cathode, it will reach to the junction point. From junction point, now it has reached to B terminal first. Okay. And from B terminal, the load current is flowing from B to A. So now the current is flowing from B to A. It means now B positive and A negative. So now the current is reversed through the load. It is now going from B to A. And then from A, it has reached to T4 anode. And then through T4 arrow, then T4 cathode, and again back to the negative plate of the supply base. Okay, once again I will show. The current is flowing from Vs positive plate, it is going to T3, from T3 it is going to B, from B to A to T4, and from T4 back to Vs. So current is flowing from B to A. So now the polarity here B is positive and A is negative. So current is reverse in load. As current is reverse in load, B terminal is positive and A terminal is negative. It means that polarity is negative. So how much is the voltage I'll get across output? Minus Vs. So in first cycle Vs was positive. In first half cycle Vs was positive, and in second half cycle Vs is negative. When Vs is positive, when T1 and T2 are conducting. When Vs is negative, when T3 and T4 are conducting. It means even if the input is DC, even if the input is not changing the polarity, but because of the conduction sequence of these four devices, we are getting the alternating output across the load. For first half cycle, the output voltage is positive. For the next half cycle, the output voltage is negative. So it is called as the inverter, which gives DC input converted into AC output. Is that clear to you? Okay. Understood operation of full bridge inverter? Now we will move towards the question part. Okay, gate questions. How to attain the gate questions? So let's see the gate questions. Now the first question of the gate examination is, this is the question of the gate exam, that in the converter circuit shown below, the switches are controlled such that output voltage V0 T is getting across the load of 400 Hertz square wave. What is the RMS value of its fundamental component in volts? Now, how to calculate, this is the derivation part, okay? So, I am not going to take the derivation over here, but I'll give you the hint that which formula you can use to calculate it. Okay, so how to calculate the RMS value of the fundamental component? The RMS value of the fundamental component is, the formula is what? V0 is equal to 2 under root 2 by pi into EDC. Now 2 root 2 divided by pi into EDC. How much EDC? 220. So now can you calculate the value for me and give me the answer? How much is the answer? 2 root 2 by pi into EDC. Yes, anybody can calculate and type the answer. Very good. 198.06. Snehal has given the answer. Very good. Anyone else? Because I said in power procession, it's better if you will take your notebook and cancel with you. Yes, very good, Pragati. So Pragati and Snehal both have calculated. I hope Rajesh will also calculate and Vaishnavi will also calculate. Okay. So the answer is 198.06. So see, the answer is, so the answer is between 196 to 200. So your answer is correct. Okay. So the range of the answer is 196 to 200 and the exact answer is 198. Okay. So everybody got the question. Now we will see the next question. So the next question is, output voltage of a single phase full bridge voltage inverter is controlled by unipolar PWM. Now unipolar means unidirectional. PWM means pulse width modulation technique with one pulse per half cycle. For the fundamental RMS component of output voltage to be 75% of DC voltage, the required pulse width in degrees will be what, with the rounding of up to 1 decimal. So I'll give you the some concept. What is pulse width? Okay. So now what is pulse width? If you will see the previous, see this is called as a pulse width. This is the pulse duration. Now this is the positive output voltage I have. Okay, the positive output voltage is in the term of pulse. So this width of the pulse is from x equal to 0 to the end point. That is called as a positive pulse. And the negative pulse is called from, say this is pi. So from pi, say 2 pi. Okay. So 0 to pi is your positive pulse and pi to pi is your negative pulse. So pulse width is the duration is 0 to pi and negative pulse width is pi to 2 pi. So pulse width is denoted by 2 into small d. 2 into small d. So that small d we are supposed to calculate. Now, what is the fundamental RMS component of output voltage? What is the formula? See, the fundamental RMS component of the single phase full bridge inverter, again the formula is what? 2 into under root 2 VDC by pi into sine of D. Now D is what? D is the half of the pulse width because 2D, 2 is the 2 into D is the pulse width. So sine of D, D will be what? Half of the pulse width. Okay, this is the formula. Now this is what? This is the RMS value of the fundamental component, which we supposed to calculate with this equation. But then the third sentence or the second half sentence has given you what? The fundamental RMS component of the output voltage is 75% of DC voltage. So can I say that this V01 RMS is equal to what? Is equal to 0.75 into VDC. That is 75% of DC voltage, this value. Okay, so 75% of DC voltage means what? 0.75 into VDC. And that is equal to what? That is equal to V01 RMS. So now you can equate these two terms. So by equating these two terms, what is the unknown parameter now? The unknown parameter VDC will get cancelled. As VDC will get cancelled, you will get the value D. So if you are going to get the D value, then from the D value, how you are going to calculate pulse width? Your pulse width will be 2 into small d. So as you are getting D value is 56.41. So here pulse width will be what? 2 into D. So pulse width is 112 into 112.82 degree, because we have calculated that is in degree. So here also we are going to get that in degree. Okay. Everybody understood how to calculate that and round off to up to one decimal. So you can see 112.8 is the correct answer. Okay. So if you are going to get the range, you can get the range also. The range will be around 112 to 130. That's it. Okay. Because what value of pi you are typing, that decides your range of the output. So is there any problem in this numerical to understand, or I can move to the next? Any problem to understand this particular? Okay, fine, very good. So now we will move towards the next. Okay, very good, very good. Okay, so now the next numerical is, this is logical numerical. Okay, so try to understand the next numerical very clearly. See, the figure has given you voltage source inverter, which is having IGBT devices. Okay, so what they are numerical? Voltage source inverter shown in the figure below is switched to provide 50 Hz square wave AC output voltage across RL load. So this is my load. At this load, I am getting AC output, and this AC output is of 50 Hz frequency. Reference polarity of V0 and reference direction of the output current I0 are indicated in the figure. The indicated in the figure means what? The current I0 they have shown in the clockwise direction. Okay, because with this arrow the current will flow in the load in clockwise direction. And what will be the polarity of the output voltage? With this clockwise direction, the upper wire will be positive and the lower wire will be negative. So V0 positive when the current is flowing in clockwise direction from upper wire to the lower wire. So V0 polarity is upper positive and lower negative, and direction of I0 is clockwise. Okay. The value of R and L also they have given. Now they have asked the question, in the interval when V0 less than 0 and I0 greater than 0, the pair of devices which conducts the load current is, means out of these 8 devices, 8 why? 4 IGBTs and 4 diodes. Now out of these 8 devices, we have to find out 2 devices which are going to carry the current. Okay. आता हे कसं काढायचं? To calculate that, first of all, we have to understand the meaning of this part. This is very important part. In the interval when V0 less than 0. See, V0 less than 0 means V0 is positive or negative. If V0 is less than 0, tell me what is V0? V0 positive or V0 negative? Yes. If V0 is less than 0, yes, very good, Rajesh. V0 negative. Okay. And I0 greater than 0, it means I0 is positive. Okay. So this sentence wants to mean you that your V0 is negative and I0 is positive. Your I0 is positive means what? Direction of current you cannot change. Your direction of the current you are supposed to take in the same way, that is clockwise. It means your I0 need to flow in the same direction. But you have to change now the polarity of V0. Your V0 is negative. So V0 negative will be what? Now your positive terminal will be lower one and negative terminal will be upper one. So when I want V0 negative, which devices I supposed to conduct or which devices supposed to carry the load current, that I found. That I need to find. Okay. आता बघा, if I want V0 negative, okay, means this particular terminal, that the lower dot, this lower dot, okay, this lower dot is now become positive. If it becomes positive, it means this dot need to connect to this positive polarity of the supply. What I said? This lower dot of V0 to be positive. When it will be positive? When this dot will connect to this positive VDC. So, which devices will connect this dot to the positive supply of VDC? Obviously, either Q3 or D3, because this dot has connected to this branch, and this branch is having the combination Q3D3 and Q2D2. Okay. Now Q2 and D2 we cannot take because Q2D2 is connected to the lower part, that means negative plate. So obviously Q2 and D2 will be crossed. Now what is the remaining option? I want to go to the positive terminal of ADC, that is at the upper side. So obviously this branch upper side is connected to what? To connect to Q3 and D3. Okay, fine. So we will keep in mind that Q3 and D3 we will have any one option. Okay. Now the second dot, that is this dot, which is having now positive polarity, but in the answer we supposed to connect to negative. Now if I want to connect it to negative, then which device combination I supposed to take? Q4 and D4, because Q4 and D4 is connected to this branch at lower side, which is connected to the negative plate of the supply. Because Mala, I have to make this dot negative. So to make this dot negative, it's supposed to go to the negative plate of the battery. Okay, so here I have now the option Q4D4 and here I have the option Q3D3. Okay, now to make the current I0, to make the current I0 in the same direction. Okay, to make the current I0 in the same direction, how will I have? Okay, how will I have the supply? Let's see. Let's see, Q2 is positive. Okay, Q2 positive, it means Q2 positive through D3. Assume that Q2, from Q2 I am going to start. Q2 positive. Now Q2 positive, I want to connect to the positive plate of the supply here. It means obviously I have to move in upward direction. If I want to move in upward direction, which device I prefer, IGBT or diode? Because IGBT arrow, through IGBT if I want to go, I have to go in the opposite direction to this arrow. So this arrow won't allow me to flow in opposite direction. So from this particular point, this lower dot, if I want to move towards positive plate of the battery, applied battery VDC, D3 will give me the path. So through D3 I will come. From D3 I am coming to the positive plate of the battery. Okay, reached. From positive plate of the battery say negative plate. From negative plate, if I want to go, then I will prefer which device, Q4 or D4? Obviously D4. So D4. And then from D4 I reach to this upper dot. So D4 has connected this upper dot to negative plate of the input battery, and D3, device D3 has connected this second dot to the positive plate of the battery. So it makes my V0 negative. That is, polarities are now reversed. The lower dot is now become positive and the upper dot has now become negative. And in which direction you got the current? Let's see again. What I got? I'm moving in battery plate positive to negative, negative to D4, D4 to upper dot has now negative, from negative again L, R. See, the current direction is not changing again my current is flowing from L to R only, so I0 is still positive. From R, I am giving to the lower dot. From lower dot, I am moving to D3, and from D3, I reach to the positive field of the battery. It means with the help of diode D3 and D4, I made V0 negative and still I0 positive. So, which is the answer? Answer is D3 and D4. Okay, so the answer is what? The answer is D3 and D4. So divides D3 and D4 makes your V0 negative and I0 still positive. Everybody understood clearly? What is the answer of this? Or once again, I should show the current path? Yes, give me. Yes or no? Or I should explain it again. How D3 and D4 make V0 negative and I0 positive. Snehal, Rajesh, and Pragati. Explain again, ma'am. Okay, fine. See, the question is what? Question is D3 and D4. Why I am taking only D3 and D4? See, first of all, try to understand these IGBT will carry the current only from upper terminal to the lower terminal. That's it, because their current should flow from collector to emitter and in the given path of the arc. So we cannot inject the current from emitter to collector because reverse way arrow current cannot flow through IGBT. Okay, that is the confirm. So whenever the current wants to flow through any device, the current will flow only in the given arrow path. Okay. जर arrow path मधनं तुम्हाला current द्यायचं आहे, if I want to have the current only in the given direction of arrow, then we supposed to follow that arrow direction. Okay. Now what is the condition? Condition is your I0 should flow in clockwise as it is because your I0 greater than 0. So I0 positive is पाहिजे. If I0 is made to be positive, the current should flow from L to R only, not from R to L. So current should flow from L to R only. But your V0 should flow now in a negative way. What? Your upper wire should have negative and your lower wire should have positive. Upper wire, if I want negative, then this dot, this junction point should go to which terminal of the input battery? Should go to negative terminal of the battery, that is lower terminal. So this dot, if I want to connect this dot, if I want to connect to the lower terminal of the battery, then this lower terminal of the battery and this dot is having in between which two devices? Q4 and D4. Fine? Q4 and D4. And out of this Q4 and D4, which will carry the current in this given path? Current कसा flow व्हायला पाहिजे? How the current needs to flow? L to R. L to R means the current needs to flow from this dot to L. From this dot to L, if the current Okay, Snehal and Rajesh, thank you for being there in the meet. Okay, because of some supply issue, there was no internet connectivity, so I was out of the meet. So we will again discuss the same issue of inverter. Now single phase bridge inverter we have almost completed. Are you clear with single phase bridge inverter? Okay. Okay. Thank you so much, Nehan and Rajesh. Okay. So now we will shift to three phase inverter. Okay. So let me again put the message on the group that it has resumed. Okay. So give me 1 minute. I'll be back. And we will start three phase inverter today. Okay. As we have completed single phase inverter. So we will see the three phase inverter part. Just give me the answer of my question. Is three phase inverter theoretical part taken in your class, regular class of power electronics? Three phase inverter with 180-degree conduction mode and 120-degree conduction mode. Has sir has taken in the class? Yes, yes. Has taken in the class. Sridhar sir has taken it or not? Yes. Rajesh and Snell, please give me the reply. Sridhar sir has taken 120-degree conduction and 180-degree conduction mode of three-phase inverter in the class or not? Because for the further numerical part, I supposed to take that. Are you there, Snehal and Rajesh?
B student.
Yeah, B student. Okay, acha, you are B
But
and
sir had taken.
you have already know that 180-degree and 120-degree. Okay, and Snehal also B student,
No, ma'am.
T student. Okay, so for Snehal, I'll take it, and for Rajesh, it will be quick revision. Fine for you? Because
Yes, yes, ma'am.
one is from third year and one is from final year, so I cannot skip that and go ahead. Okay, and I cannot deeply take also, so that Rajesh time will be wasted otherwise. Okay, so let me find the solution. We will go very briefly and quickly through three phase inverter. So three phase inverter is nothing but what? It gives output of three phase, so it is called as a three phase inverter, Snehal. And output of each inverter is displayed by 120-degree because it is a three-phase output. So R, Y, B or A, B, C are the three phases, and we know that the voltages and currents of three phase are 120-degree apart from each other. If I am going to convert single phase inverter to give the output of three phase, then the way we have seen single phase bridge inverter requires four devices. Then these four devices, if I'll club three different single phase bridge inverter, then the total devices will be 12, and then it will be very bulky circuit, that 12 devices, then it's 12 triggering devices or firing circuits 12, then commutation circuit 12. So instead of having three single phase bridge inverter give three phase output, we are using directly three phase inverter, which is very simple, having only three branches, and each branch is having only two devices. So total devices in the three phase inverter are six. Because six devices are in the complete circuit, the circuit is also called as a six-step inverter. So three-phase inverter is also called as a six-step inverter. So please don't confuse. If the question comes in the part that six-step inverter is used so and so, so you should be able to recognize that six-step inverter means nothing but three-phase inverter. Okay, and four-step inverter is nothing but single-phase inverter. Okay. Now, why it is called as a step? Because step is nothing but changing in firing angle from one SCR to the another SCR in a proper sequence. It means I have conducted T1, T2 in first half cycle in single phase bridge, and then I conducted T3 and T4. Okay, so T3 and T4 is having one sequence, and T1 and T2 is another sequence. So T1, T2 conducted together, then T3, T4 conducted together. So we are changing the firing from one combination to the another combination in a proper sequence, and that duration is called as a step. So now because it is a six-step inverter, and we know that full cycle of AC is 360 degree. So if a full cycle I'll divide into six steps, then what will be the duration of each step? The duration of each step will be 60 degree. So what is the relation between 60 degree, 360 degree step and the sixth number? The relation is to generate a full cycle of AC sinusoidal supply of the duration 360 degree. We are using six-step inverter which is having six devices. In these six devices, each device is going to conduct for 60 degree duration, so that each device conduct for 60 degree duration, then all the devices will conduct one after the other, and 60 degree, 60 degree, 60 degree each step. If I'll have total six step in 360 degree duration. So how many steps I'll get in my cycle? I'll have six step in my cycle, so that it is one of the six step inverter. I'll repeat the concept again. To generate a full cycle of 360 degree duration of AC sinusoidal waveform, there are total six devices we are using in an inverter, which is called as a six-step inverter. To conduct these six devices, each device is going to conduct for 60 degree duration. So when each device is conducting for 60 degree duration, then one after the other, if I am going to have six devices in a proper sequence, then how many steps I'll have? I'll have six steps in a full cycle of 360 degree duration, so that the complete circuit is called as a six-step inverter. Is that clear? This
Yes, yes,
concept
ma'am.
is clear, both Rajesh and Snehal?
Yes.
Yes,
Okay.
ma'am.
Yes, very good. So now see these device, this circuit. Now this circuit is, it's called as a three-phase inverter with IGBT. As I said that why IGBT and MOSFETs are widely used in inverter, because commutation circuit separately we don't require.
Ma'am,
Yes, 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 Rajesh.
presentation is not
Presentation is
clear.
not visible. Okay, okay, okay. Sorry. Okay. Oh. Is it feasible?
Yes, ma'am.
Okay, so what I want to say for Snehal, I'll explain. Okay, so what I have given you, the here you have given three sentences that in each cycle of 360-degree of a sinusoidal waveform, there are six devices we are using. Okay, and in these six devices, each device is conducting for 60-degree duration. So when I'm conducting six devices one after the other, then 60 degree, 60 degree, 60 degree, like this, how many steps I'll have? I will have six steps. So it is called as a six-step inverter because six devices, each device will have 60 degree. So like that six step I'm going to have for generation of each cycle. Okay. Now three-phase inverter. So in this three-phase inverter again we have six IGBTs T1, T2, T3, T4, T5, T6. These are basically transistors. Okay. So T1, T2, T3, T4, T5, T6. And these are anti-parallel diodes D1, D2, D3, D4, D5, D6. So six IGBTs and six anti-parallel diodes we have used. This is the input DC voltage EDC we have given. Then this is the three-phase load. This three-phase load is having three branches R, 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 R. This is called as a three-phase inverter of IGBT and star connected load. Okay, as we have three-phase inverter, so the load will be three-phase. So with the help of three-phase connections, either I have star connected load or delta connected load. So here I have star connected load. Okay. So now in the star connection, first of all there are two modes. Which are the two modes? One is 180-degree conduction mode, another one is 120-degree conduction mode. So in 180-degree conduction mode, three SCRs are conducting together. Now why three SCRs are conducting together? Because each SCR, we have seen each SCR is conducting for 60-degree duration. So for 60 degree, if each device is conducting, then for 180-degree conduction, how many devices will come in picture? Whereas another scheme is called as a 120-degree conduction. In 120-degree conduction mode, each SCR is having 60 degree step. So how many step will be equal to 120 degree? 60 into 2. So in 120-degree conduction mode, two SCRs are conducting in each interval. That is the basic difference. In 180-degree conduction mode, three devices conducts at a time. And in 120-degree conduction, two devices conducts at a time. Okay. So the first scheme we will see 180-degree conduction. In 180-degree conduction, the full cycle of 360 degree, we have divided into six intervals. So interval 1, interval 2, 3, 4, 5, 6. Each interval is of 60 degree. Okay, I'll show you the waveform. See, this is my six intervals. First interval, second interval, third interval, fourth interval, fifth interval, and sixth interval. So here I have 360 duration completed from 0 to here I have 360-degree completed this line. Okay, so this is my fifth line. 1, 2, 3, 4, 5 and 6. So here I have completed 6 duration. Okay, clearly understood? Okay, so this is first line, second line, third line, fourth line, fifth line and sixth line. So sixth line is going to give me the sixth interval. So here it is my cycle ends. Okay, and now I have six devices. So see, in a proper sequence, I am going to conduct all the devices. First, I have given the gate pulse to first SCR, so IG1. For how much duration? For 180-degree duration. Why? Because the scheme is of 180-degree conduction mode. So 180-degree duration means how many steps? 1, 2 and 3. Because one step is of how much degree? 60 degree. I have to conduct SCR for 180-degree conduction mode. It means that SCR need to be under conduction mode for 180-degree duration. So for how many steps I have to continue that gate pulse? For 3 steps I have to continue that gate pulse. So first interval, second interval as well as third interval. So it will be completely 180-degree conduction. After first SCR, I have to now switch on SCR2. So IG2 I have to apply. So IG2 when I'll apply after 60 degree of SCR1. So SCR1 has started at T equal to 0. After 60 degree duration, SCR2 will start. Again, SCR2 will conduct for how much duration? For 180 degree duration. So, which step? Second step, third step, and fourth step. Second interval, third interval, and a fourth interval. IG2 will continue. Now, third SCR. Third SCR will conduct at what time? Third SCR will conduct 60 degree after SCR2. Now, 60 degree after SCR2 means what? In interval 1, get 1 started SCR1. In interval 2, get 2 started SCR2. In interval 3, gate 3 has started SCR3. So this SCR3 has started 60 degree after gate 2. Again this SCR3 will have conduction 180 degree continuously. So third interval, fourth interval, fifth interval. Okay. Then the fourth. Like that the sequence is. If I'll continue the same sequence, some waveforms you will get here this side also. Now, see, in IG1, this side, no interval, negative y-axis. Here also, IG2, negative y-axis cannot have conduction. Or I'll have here also, I have two steps only, or two intervals only. Here I have only three intervals. But for IG5 and IG6, compared to the starting age, that is the fifth interval, IG5 has started in fifth interval. Before fifth interval, it is having four intervals, 1, 2, 3, 4. So if I left second, third and fourth, that is its 180 degree negative half cycle, then you have one more period to conduct. So that's why IG5 is having one more little bit one step conduction over here also. Okay, in first interval. So in first interval, IG5 is going to conduct for 60 degree step, and then it is having 180 degree conduction here also, fifth, sixth, and then again seventh. Sixth SCR. Sixth SCR has conducted in sixth interval. So again for sixth, seventh, eighth interval. Again here before sixth, it will have its turn of time of 180 degree, that is negative half cycle. With respect to that, again it is having two more steps, that is first, second. So only IG5 and IG6 now you will see that they are going to have the conduction even before their positive half cycle. So if looking at this particular scheme, it is very easy to understand that in interval number 1, which three SCRs are in conduction? In interval number 1, see, in this interval number 1, which SCRs are in conduction? SCR1, 2 is off, 3 is off, 4 is off, but 5 is on, and 6 is also on. So in interval 1, 1, 5 and 6 are in conduction mode. Okay, so now let's see the table. In interval number 1, T1, T6 and T5, these three are in conduction mode. Got it? How I got these three numbers in interval number 1? Because this scheme gives me clear idea. In interval number 1, first SCR, fifth SCR and sixth SCR are in conduction mode. Mummy, here, why I have not mentioned 156? Why I mentioned 165? Because, see the diagram. 1 is coming in first branch, which is called as a A branch, because this A branch connected to A load. Okay. Then B branch of a load. B branch is connected to third and sixth. Here sixth is in middle branch, B branch. And C branch is connected to the fifth and second device. So which devices are in conduction mode of interval number 1? 1, 5, 6. But then 1, 5, 6, I'll change the sequence of phase ACB I'll have. But what is the standard sequence? ABC. So as per the standard sequence of phase sequence R by B, like that ABC, how will I write the name of the devices? A connected to first, so 1. B connected to middle branch. In middle branch, 6 is under conduction mode, so 6. And C branch is connected to fifth and second. Out of this fifth and second, fifth is under conduction mode. So how will I represent in load? First device, sixth device, and fifth device. It means A branch is because of T1, B branch is because of 6, and C branch is because of 5. So here I have written the names 1, 6, 5. So first notation is giving me A branch node, second notation is giving me B branch node, and third notation is giving me C branch node. Okay? Now interval number 2. In interval number 2, which devices are in conduction mode? First, second, and 6. First, second, and 6. How will I denote them first, second, and 6? First connected to A branch, 6 connected to B branch, and second connected to C branch. So I have noted is T1, T6, and T2. Okay, let's see the diagram again. Second is in C branch, 6th is in B branch, and T1 is in A branch. So with respect to phase sequence A, B, C, how will I note them in the conduction sequence? 1, 6, and 2. So T1, T6, and T2. Similarly, in interval number 3, these devices are conduction. Interval number 3, 1, oh, T1, T2, and T3. Now in third interval, T3 will come. No? Okay, as 6 will go out, T3 will come. Here is the magic I forgot to tell you. See, when I am switching from first interval to the second interval, okay, here in second interval T2 comes in picture, and who exit? 5 has exited. See, 5 is going out and second is coming in. In third interval, third is coming in and 6 is going out. Okay, see. In first, second, and third, T1 is continuously conduction. In first interval, 5 was there, but then in second interval, T2 in. T2 has entered. In third interval, T2 will remain now and T3 will come. It means what? Just see, if you will look at the table, T1 continuously for 3 continuous intervals is coming because it is 180-degree conduction. Once T2 enter, T2 will remain for 3 durations, 3 intervals continuously. Second, third, fourth. Once T3 enter, T3 will remain there in the conduction mode for next 3 intervals, that is third, fourth, and fifth. Okay, but when T2 comes in, when T2 will come in when T5 is going out. Why it is so? Because if you will see the diagram, 5 and second is devices, 5, fifth device and second devices are connected in the same branch. So in the same branch, either upper device will be in the circuit or lower device will be in the circuit. Because when both the devices are in the circuit, the short branch will be completely short, and we cannot do that. Okay, branch short नहीं करेंगे अपने. So if I want to avoid that, either one device will be there in the connection, either upper or lower. So when upper is going out, immediately lower is coming in. So when fifth is going out, it's lower branch, that is lower device, T2 is coming in. Similarly here T6 and T3, let's just see. When T6 is going out, immediately its upper device is coming in, that is T3. Okay? So see, T6 is going out immediately after T3 is coming in. Now the next, after T3, who will be in the proper sequence? T4. So fourth interval. See, in the fourth interval who are in conduction, first is now going out. So who are there in conduction? 2, 3 and 4. 2, 3 and 4. Why 4 come in? Because first go out. How first and 4 are related? Because first and 4 are connected in the same branch. First device and 4 device connected in the same branch. So when 1 is going out, who is supposed to come in? 4 comes supposed to in. So 4. So like that the table we have to prepare. This table is very important. Okay, so T4 I am taking in fourth interval. So 4 device will remain for 3 intervals. T4, T5, T6. Here T4 for fourth interval. Again T4 is here for fifth. Again T4 is here for sixth. For 4 consecutive intervals. Oh sorry, 4 devices consecutively for 3 intervals. After T4, who will come in? T5. But T5 will continue for 3 intervals. Fifth, sixth, and first. After T5, who will come in? T6. So T6 will be under conduction mode 6 first and second. Clear? This table, no, you're supposed to properly manage because in the examination also, no, they'll give you the circuit and you supposed to maintain or you supposed to prepare a table and you supposed to prepare your gate scheme and then you are able to answer the questions. Okay? Until and unless you will not able to prepare a table properly, you will not be able to give the answer of the questions properly. Okay? So, any problem now to understand the table and gating scheme? Even Rajesh also, if you have any doubt, you can ask me. Because, okay, preparing gating scheme and preparing a table is very important for any given circuit. तुम्हाला कोणतेही सर्किट देतील आणि त्या सर्किटचं तुम्हाला टेबल प्रिपेअर करायला लागेल. Okay, very good. So you understood clearly. Okay. So now 3 plus inverter, now it's very easy. Let's see. Circuit now you can easily understand. Let's see the first interval. Okay, in first interval, which devices are in conduction mode? First, sixth, and fifth. Okay, first, this device, upper. A branch upper. Sixth, B branch lower. Fifth, C branch upper. Okay, so another three devices just ignore from the circuit. Now we will see the equivalent circuit. How the circuit will look like? Simple circuit. This is EDC input. So EDC input. Okay. A branch is connected to this junction point. This junction point is connected to T1 branch. This T1 is under conduction mode. So through T1, this A branch through this junction point connected which terminal of the supply? Positive plate of the supply. So ultimately A branch of the load is connected this positive plate of the supply. Positive plate of the supply through T1, it is connected to the junction point and this junction point is connected to the A branch of the load. So A branch of the load is connected where? A branch of the load is connected to the positive plate of EDC. Okay. Similarly, B branch. Now B branch is connected to this junction point, second branch junction point, second vertical branch. Second vertical branch is having which conduction? T6 conduction. So B branch will connect where? B branch will connect to T6 and T6 connected where? T6 is connected to the negative plate of the battery. So B branch of the load is connected where? To the negative plate of the battery. Okay. Then fifth branch. Fifth branch is the third branch, vertical part, upper part. So C branch is connected to the load. So C branch of the load is connected to the junction point. And this junction point is connected to the T5 device. T5 device is nothing but the C last branch, upper part, and it is going where? It is going to the positive plate of the battery. So C terminal is also going to the positive plate of the battery. And neutral is common in between all three branches of the load. So here neutral is common. C. So how it is looking? A branch and C branches are in parallel and B branch separate. A and C parallel combination is going to connect between positive plate of the battery and neutral, and B branch is connected between negative plate of the battery and neutral. Fine. And all three resistances of the magnitude R, and R. So now we have to find out the voltages and current. Okay. So now which voltage is the voltage across each load? So what A branch will have the load voltage? The phase voltage coming across A branch is called as a VAN. A branch will have the voltage AN. C branch will have the voltage CN and B branch will have the voltage VN. As we are measuring the voltage with respect to neutral, so this EAN, that is voltage EAN, ECN and EBN are called as what? Phase voltages. Because we are measuring these voltages with respect to neutral. So these are my phase voltages. Now these voltages are phase voltages. So to know these phase voltages, I suppose to know the current flow through each branch. Because voltage is equal to I into R. So how will I find out the current flow through each branch? See, the current supplied by the EDC battery, say I. Okay. Then this I will be divided into two different parts. One is flowing through A branch, another one is flowing through C branch. Okay. And then at this junction point, again these two branches will have together current, and again this current I will flow through as it is through B branch. Okay. Now, here I have given what? Here I have given I1 as the supply current. आता हा I1 supply current है. This I1 supply current, how will I find out? Supply voltage divided by total resistance. How much is the supply voltage in DC? What is the total resistance of the circuit? Total resistance of the circuit is the combination of all these three branch resistance. Now, what is the combination of these three branch resistance? Here, two resistances are in parallel. So, what will be the magnitude? R in parallel with R. R in parallel with R means what? R into R divided by R plus R. So, R into R is R square divided by R plus R, it means 2R. So, R square divided by 2R, it will be what? R by 2. So, this R by 2 is the equivalent resistance. This equivalent resistance of a parallel combination is in series with B branch resistance. How much is the value of B branch resistance? R. So, R plus R by 2, it means 1 plus 0.5. 1 plus 0.5 is what? 1.5. 1.5 is nothing but what? 3 by 2. So, what is my R equivalent? 3 by 2 into R. Have you understood that? These are the two equal values are in parallel. Okay. So, R in parallel with R. So, what is equivalent resistance? R equivalent resistance is R by 2. R by 2 nothing but what? It is 3 by 2 into R. So, total resistance of the circuit is 3R by 2. 3R by 2. I will find out the current I, supply current. What will be my supply current? Voltage divided by resistance. What is voltage? EDC. What is divided by resistance? 3R by 2. 2 will come in numerator because the full is in denominator. So 2 is in numerator. So what is my total current? 2 EDC divided by 3R. This current is flowing from this battery. Okay. As this current is flowing through the battery, what will be the voltage EAN and ECN? They are in parallel. If they are in parallel, they will have the same voltage. So their voltages are equal. Why the voltages are equal? Because resistances are in parallel. If the resistances are in parallel, they are having same voltages. What will be their drop? Current into their equivalent resistance. What is current? I1. What is the equivalent resistance? R by 2. R in parallel with R. What is the equivalent resistance? R by 2. So what is the voltage? EDC divided by 3. Why EDC divided by 3? This current into R by 2. So 2 2 will get cancelled. RR will get cancelled. What is the term remaining? Term remaining is EDC by 3. So EDC by 3. What is EDC by 3? It's the voltage appear between A and neutral and C and neutral. So EN and EC. What is my third voltage? EBN. EBN is connected in such a way that I am calling EBN BN. When I am calling BN means current supposed to flow from B to N, but current is flowing from N to B. It means supply current is negative for my BN voltage. So I am taking minus I1 because I am calling the name BN, but current is actually flowing from N to B. So current here it is negative into the resistance of that branch. What is the resistance of this branch? R. So I1 into R. What is the magnitude? Minus 2 EDC by 3. Okay. So this way you can calculate for all intervals. Okay. One interval I have given you sample calculation. And then you can plot the waveform. So EAN, EBN and ECN. The plotting is EN is EDC by 3 in first interval. Okay. CN is also equal. That is EDC by 3. Okay. And EBN was negative. That is minus 2 EDC by 3. So first level is EDC by 3 in positive second. Second level is 2 EDC by 3 in positive second. In negative second, the first level is minus EDC by 3 and the second level is minus 2 EDC by 3. So level wise you can plot the waveform, and if you will see, the waveform is having 3 steps in positive second, 3 steps in negative second. Each step is of 60 degree. So the complete duration of positive second is 180 degree Complete duration of negative half cycle is 180 degree. So like that, every phase voltage, see, A phase voltage has started from 0, whereas B phase voltage started its positive half cycle after 120 degree with respect to A. It means it is proper because A and B should be 120 degree displaced each other. So if A started at 0, B should start after 120 degree. And with respect to this point, C should start after 120 degree with respect to B. So here it's a B start point. So after two intervals, here B started. It means C also 120 degree apart from B. So these are all three phase voltages which we have seen in three phase inverter. And then the line voltages also we can calculate. How to calculate line voltages? EAB, EBC and ECA. How will I calculate EAB? AB, A minus B, it will give AB. A minus B means what? EAN minus EBN. I'll get EAB. EAN minus EBN. So see now, EAN minus EBN, if I do EAN, EAN कितनी है? EDC by 2. EBN कितनी है? Minus 2 EDC by 2. I'll subtract them. So one term minus of minus second term. So it will be nothing but addition. EDC by 3 minus in bracket minus 2 EDC by 3. So it will be nothing but EDC by 3 plus 2 EDC by 3. So 3 EDC by 3, it is 3 will get cancelled, it will be EDC. So let's see, it is EDC. So these mathematical terms you can do and you can find out the level of EAB, EBC and ECA. Okay. So this is 180 degree conduction. So thoroughly you want to understand the waveform. For that you supposed to work, but okay. I know that within this half an hour discussion we cannot understand or you cannot clearly do your concepts well. You have to at least do some paperwork. Okay. And with this paperwork you will be able to do that waveform pattern. But if you know 180 degree conduction, it will be very simple to understand 120 degree. 120 degree is very simple because there are only two devices. Now why two devices I said? Because each device is having 60 degree step. So to make 120 degree conduction, obviously how many devices I have to take into consideration? Only two devices. So here in 120 degree conduction, only two devices comes in picture. But then what is the disadvantage? Because here only two devices are in conduction mode, third branch of the load is always floating. It is open. See, if I am comparing first interval in 120 degree conduction mode, I am having only two devices, 1 and 6. Because of 1, A branch is in circuit. Because of 6, B branch is in circuit. But then C branch is not connected in the circuit. C branch is floating. Why? Because fifth device and second device both are not in picture. So C branch is floated. So this gives very large harmonics. So because of this problem, 180 degree conduction mode is more preferable and 120 degree conduction mode is not preferable. Like that. Okay, so these are the three phase inverters. I will give you the waveforms, 120 degree pattern. And it is a 120 degree, there are only two levels, plus ADC by 2, minus ADC by 2. आता इथे दोनच level का है? If you will see, there are only two resistors. One is A and another one is B. Both are in series. So obviously, full voltage will be divided into two equal parts. Here will be half and here will be half. The name AN. A is positive, N is negative. So current is flowing from A. So AN will be positive. Okay, so A is positive, so AN is plus ADC by 2. The name second is BN. BN means what? The current should flow from B to N. But here the current is actually flowing from the circuit A to N and N to B. Current कैसा चल रहा है? N to B तक. It means NB is actually the flow of path of the current. But we want BN. So BN will be what? BN will be negative voltage. Because current is flowing from N to B, but I am measuring the voltage from B to N. So my voltage will be negative. How much? Remaining half part. That is minus ADC by 2. So positive half part I am getting across AN and negative half part I am getting across BN. So half the voltage across A branch and half the voltage across B branch. So that the voltage is giving in this branch. So an is positive ADC by 2. The same interval Vn is minus ADC by 2. Okay, so like that you will have the waveform. I hope three-phase inverter at least some concept I have cleared. Okay, so next time we will only see the question numerical part because I any more theory I will not cover now. Theory part which for your understanding I supposed to cover I have already taken that, and then another topic like converter, buck boost chopper or buck boost and say regulator. Okay, these are the topics also we have. So converter part also sir has taken in the class, and buck boost part also sir has taken in the class. So we will not waste our time to cover up theory. Inverter I have taken in theory point of view because three-phase inverter Snehal may not be aware. So I have stressed that three-phase part. But in the next session, no, we will only see the numericals on the topic of converter, buck boost regulator, and if suppose the time permits, AC voltage control. Okay. So I hope you like the session, and I hope that next session also you will join. I'll let you know when I'll conduct the next session. If suppose afternoon period is free, suppose nobody is taking any class in the afternoon, then I'll take 1 hour session in the afternoon if you are interested. So you give me your willing point whether in the afternoon you are interested or not, or otherwise I'll conduct on some another days. But then working periods or working days are difficult to have the sessions. Okay, so you only tell me, you can WhatsApp me your convenience, and then like that we will manage. Okay, so Snehal, Rajesh, and Sagar, you can WhatsApp me your convenient schedule, and then on the day of on that respective day 1 hour session we will have for remaining numerical practice. Okay, any problem, any doubt? Yes, any doubt you can ask, otherwise I'll end the session. Any difficulty? Okay, fine, very good. Okay, thank you, thank you, thank you.